Water may be bound to rocks across the moon's entire surface all day long, a new study finds. This finding suggests that large amounts of water molecules could be permanently present on the surface of the moon, the study's researchers said. Previous research suggested that water molecules could exist across the surface of the moon. This water does not exist in the form of ice, save perhaps in the permanent shadows of some craters at the lunar poles. Instead, it is chemically bound to rocks in the uppermost layer of the lunar surface, to a depth of less than a micrometer (0.00004 inches. Study lead author Christian Wohler, a physicist at the Technical University of Dortmund in Germany, told Space.com. Photos. The search for water on the moon. Researchers observed how much water and hydroxyl was bound to the moon's surface during the lunar morning, midday and afternoon. Bluish colors mean strong absorption, and reddish colors mean weak absorption. Credit Image Analysis Group, Technical University of Dortmund. The earlier work found that such lunar water might be bound to rocks only at high latitudes, away from the moon's equator. Researchers suggested this might be because sunlight is stronger at the lunar equator, leading heat or solar ultraviolet rays to remove most or all of the water there, Wohler said. To learn more about the behavior of water on the moon, Wohler and his colleagues analyzed lunar data from NASA's Moon Mineralogy Mapper instrument on India's Chandrayaan-1 spacecraft. They focused on wavelengths of light that served as signatures of water. The researchers also looked for hydroxyl, a molecule whose composition is like that of water, but with one less hydrogen atom. The scientists looked at the entire lunar surface at 3 different times in the day: morning, midday and afternoon. Surprisingly, water or hydroxyl can be detected basically all over the moon at all local times of day, Wohler said. Highland regions at high latitudes showed stronger signs of water or hydroxyl during the morning and evening than at midday. This makes sense if sunlight is getting rid of molecules from rocks there, Wohler said, as sunlight is stronger at midday. However, closer to the equator, signs of water or hydroxyl remained nearly constant in the Highlands regardless of the time of day, the researchers found. This suggests that some of the moon's water or hydroxyl may be bound strongly enough to lunar rock to resist evaporation from heat or destruction from ultraviolet rays, the researchers said. Previous research suggested that water or hydroxyl on the moon likely originated from chemical reactions between oxygen molecules in lunar rock and protons in the solar wind, a stream of charged particles constantly flowing from the sun. Such water or hydroxyl would likely be only loosely bound to the lunar surface, Wohler said. These new findings suggest that at least some of the moon's water or hydroxyl is bound more strongly, Wohler said. Previous research suggested that one source of these molecules could be water-laden minerals, while another source could be a reservoir at a large depth, Wohler said. The researchers plan to investigate how water or hydroxyl on the moon behaves depending on the kind of surface it is found on, information that could help them better understand the molecule's origins and behavior, Wohler said. Upcoming Russian lunar landers will acquire data that might be very insightful in this respect, he added. The scientists detailed their findings online September 8 in the journal Science Advances. Follow Charles Q. Choi on Twitter at Skoy. Follow us at space.com, Facebook and Google. Original article on space.com.